Okay, this lesson is for Mrs. Cucci's College Now Precalculus class. We are on lesson 4.3, logarithmic functions and graphs, and we left off on page 4.1. All right. Yes. Okay, so we've got some word problems that we need to deal with. First one is based on walking speed. In a study done by psychologists, it was found that the average walking speed, W, in feet per second of a person living in the city of population P in thousands is given by the function W of P equals 0.37 natural log of P plus 0.05. So for A, we're going to look at the population of Savannah, Georgia, being 136,286. We want to find the average walking speed of people living in Savannah at that time. Okay, so here's what we're going to do. Okay, so what we're going to do in order to find out the average walking speed for that population is we plug in the population for P. So this is A. So we get W of 136.286, because remember it's in thousands, so we need to adjust for that, equals 0.37 ln of 136.286 plus 0.05. And we're simply going to plug this into our calculator, and we're going to get an average walking speed of approximately 1.9. And that's going to be feet per second. You can clip it right in there for me, honey, into your classroom. Okay, so for B, what we're looking at is, given the population of Philadelphia is 1,526,006, we're going to find the average walking speed for the people living in Philly. So same thing, we need to change that to thousands, and we're going to substitute that in. So in thousands, we're going to have 1,526.006. And we're going to plug that right in. And that's going to give us 2.7 feet per second. Okay, so C says graph the function, and we're going to graph this right on our graphing calculator. Okay, so Control I, add graph. And we're going to put in our function, 0.37 natural log of x plus 0.05. So here's our graph. And if we want to adjust the window so that it's more appropriate looking, we can absolutely do that. Menu, window settings. We really don't need negative time. If the x-axis is our time in seconds, we're not going to deal with negative time. So we're going to start our x minimum at 0. Our x maximum, let's say we go to 600. We want to give ourselves some time to look through. The maximum y value, we're not going to go incredibly fast because remember we are walking, so let's max that out at 4. Sorry, this needs to be minimum. We're not going to go any slower than 0, so let's do 0 and 4. And here's a nice view of that function. Okay. So that part D wants us to find the approximate population of a city that is walking 2 feet per second. So we're going to have to kind of work in a different order here. And what we're going to do is we're going to take our function, and instead of plugging in for P, we're going to plug in for W of P. Okay? So it's going to become 2 equals 0.37 ln of P plus 0.05. Okay, so we're going to start by subtracting over that 0.05. And then dividing, because our goal is to get that natural log alone. God bless you. I'm going to use my calculator. 2 minus 0.05 divided by 0.37. I get 5.27027. And natural log of P. So the goal is to solve for P here. So in order to solve a logarithm, we need to take it and put it back into exponential. Remember, the base of a natural log is e. So it becomes e to the 5.27027, and that equals P. And we're just going to evaluate that using our calculator. So e, and I'm going to use to the answer. It's going to bring this answer down for me. And I get 194.469. Now, keep in mind, we said that population was in terms of thousands, so we have to remember that. So we're at about 194. Let's say we round it here, 194,500. It's an approximation of the population. Okay. All right. We're going to do one more. Oh, no, we're not. Okay. All right. So make sure you come prepared with any questions. It's a very short video today, and I will be checking your notes to make sure that you got this stuff done. Thanks, guys.